Hello guys, how are you? This is your teacher Mubin, and now I have decided to deliver my lecture in English. So, what are we talking about? We are talking about dynamics. We have solved the chapter kinematics, and we are to start dynamics. What is dynamics? Dynamics is the branch of physics which deals of physics which deals with study of cause of motion. What? Cause of motion. What is this? Okay, in kinematics, we were studying the motion without the cause. We are studying the type of motion without the cause of motion. In this branch, we are studying the cause of motion, not the type. Are you getting me? So, getting started, let's just discuss some O levels concepts like Newton's first law. Newton first law, that is also called law of inertia. Law of inertia. Now, what is law of inertia? Law of inertia states that a body continues its state of rest or of continuous motion until no net force acts on it. Isn't it? It means that, for example, here is a table. Okay, here is a table. If no one pushes it or pulls it, is it possible that it moves? No, it is not possible. Exactly, if a body is moving, there is no friction, no air resistance, no opposing force. Why this body stops? Can it stop or not? No, it can't be stopped. Okay. And talking about Newton's second law states that force is equal to ma. We'll talk about what is ma later in this lecture. And the third law states that every action has an equal has an equal but opposite reaction. But opposite reaction. So, so for example, if you if you blow a balloon, the balloon will throw air outside, and the air will push it towards this direction. Isn't it? This is called law of Newton third law. Okay, but the action and reaction are equal but two opposite bodies. The action is on the air, the reaction is on balloon. Are you getting me? Talking about next. Let's get to the topic. Our major topic is force. What is force? Uh, yeah, I know that we have learned that force is a push or pull. Basically, force is equivalent to mass times velocity. Oh, sorry, mass times acceleration. What is it? It is mass times acceleration. Okay. Now, let's jump into the major topic, the momentum. The momentum. This is the topic in which there are many questions out of the board. Okay. Before jumping into momentum, let me give you some example. If a bike and a car is rushing towards you, so uh, who is easy to stop? Who is easy to stop? What do you think? I think bike, isn't it? Bike is easy to stop. Why? Because bike has lesser mass. Because bike has lesser mass. Okay. Now consider two bikes are coming towards you of same mass, but bike one has greater velocity and bike two has a lower velocity. Who is easy to stop? I think this one because it has lower velocity. Are you getting me? So talking separately about mass and velocity, we combine these two quantities into one quantity called momentum. Okay, momentum is the mass times velocity of a body. Okay, momentum is what? Momentum is mass times velocity of the body. For example, consider this: a 1 kg ball is rushing towards you with a 10 meter per second velocity, and a zero point 0.1 kg ball is rushing towards you with a 100 meter per second velocity. What do you think hits the most? They have the same impact. They have the same impact on you, because 10 multiplied by 1 and 100 multiplied by 0.1. The answer is 10. So, talking separately about their masses and velocities, we have given it the name momentum. Are you getting it? Okay. So, let's talk about momentum. Momentum is mass times velocity. What it tells? It tells about the quantity of motion of a body. Quantity of what? Quantity of motion. Moving forward. Okay. Now, what is change in momentum? How change in momentum can be determined? Okay, change in momentum is like, consider a body moving with a velocity of initial vi having a mass m. What is its initial momentum? What is its initial momentum? Pi. Pi would be equal to mvi. Then it stops due to certain problems and its velocity becomes vf. What would be its momentum? Its momentum would be pf, that is equal to mvf. Are you getting me? So, what is change in momentum equivalent to pf minus pi is equal to mvf minus mvi. But the thing is, this is not only the real. Okay, consider this: a jet. Consider a jet. Okay. No, I know my diagram is not so well. It is throwing its fuel. It is burning its fuel so that we can move forward. So the mass of the aircraft is decreasing. The mass of the aircraft is decreasing. So the momentum Pf minus Pi would be equal to final mass minus initial mass times velocity, because the plane was moving with a uniform velocity. If the velocity is also changing, so we will say that mvf and vf minus mivi. What does it mean? It means that the mass has changed and the velocity has changed. And now the product of mass and velocity, final, and the initial velocity and mass would be subtracted to get the change in momentum. Are you getting me? Okay. What do you think? What causes the change in momentum? Why a body changes its momentum? Is it mad? Does it itself? No. This can only be occur when a force acts on it. Are you getting me? For example, a car is moving with a velocity of 30 meter per second, suddenly gains a 50 meter per second velocity. So, how does it happen? An accelerating force acts on it and it moves with a higher velocity. So, so the change in momentum, the change in momentum, consider this: Pf minus Pi, okay. What would happen if we take change in momentum in a unit time? Consider this: that body gains 20 meter per second in 10 seconds time. Okay, okay. This is called change in momentum per unit time. Per unit time. Okay. So can we write this MVF minus MVI upon time? Taking M common, it is VF minus VI upon T. Okay, my friends, what this formula states to you? What this formula states to you? This is acceleration. What is this? This is acceleration. It means that and the mass times acceleration is equal to force. It means that the force is equivalent to change in momentum. Yeah, I know that my writing is not very well, but please adjust it. Yeah, I will also do some past papers as well. Please focus on this theory because this theory is more important. More important. One question always comes from this topic in exams. Okay, so we have learned that force is equal to ma and that is equal to pf minus pi upon p. So okay, now now we can state that force is equal to Pf minus Pi upon P. It means that force is equal to rate of change of momentum. Okay, let's take time here. It becomes F into T is equal to Pf minus Pi. Okay, and we name this product of force and time as impulse. What? It is impulse. Pf minus Pi. Now, now. What is this impulse? Let me give you some example. A very sudden change in momentum. A very sudden change in momentum is called impulse. What is impulse? Let me write it over here. A very sudden change in momentum is known as is known as momentum. Okay. Now, what does this sudden change in momentum means? Consider that a bowler is bowling a ball. Yeah, yeah, this is a phrase like a bowler is bowling a ball and a batsman is ready to kick it off. Okay, so the very instant when the ball strikes the bat and moves backward, this very instant the change in momentum is called impulse. Okay. Yes, you can also consider very sudden change in impulse as jerk. Okay, let me give you some more examples like that. Consider a nail, okay, and a hammer, and a hammer, okay. When the hammer is hammering the nail, the very instant when they strike each other, the change in momentum is equal to impulse. Are you getting me? There's a lot more theory about impulse. Let me give you some other examples. Do you know hardness of helmet doesn't matter? Hardness of helmet doesn't matters in a bike. It means that it is not necessary to make your helmet hard. How does helmet protects your head? The helmet just increases the time. Okay, see that the change in momentum is equal to force times velocity. If the time is more, the force would decrease. Are you getting me? So the helmet is like this. If this is a head, the helmet is like a bit loose. So it strikes to the human head, increases a time of the impulse a bit, and the force decreases in this manner. Are you getting me? Okay, let us give some questions over here. Consider this. We are given with the example. Okay, let me clear you the direction of this is momentum as well. Direction of the momentum of momentum. The direction of the momentum is same as velocity. The direction of the momentum is same as velocity. Let me give you a little trick. Let me give you a little trick. If a scalar is multiplied by a vector, so the direction of the resultant scalar would be same as the vector. Okay, the direction would be same. So the direction of velocity is determined the velocity of the direction of the momentum. Okay, so talking about some graphs, talking about some graphs, consider this. If we are given with a displacement time graph of this, what would be the momentum time graph? If we are given with the displacement time graph of this, okay, I had told you how to draw a velocity time graph with a displacement time graph. This slope is uniform, isn't it? This slope is uniform slope. Okay. So the velocity would also be uniform throughout the journey, and the momentum would be also uniform throughout the journey. What would be the acceleration over here? The acceleration would be what? Give me answers. The acceleration would be zero. Okay, because the velocity isn't changing. Let me give you an example. Consider this. There's a racket over here. Yeah, this is. Oh no, 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 no. There's software English, my friends. I have not made this. So consider this a racket. Okay. Consider a ball rushing towards it with a velocity of 30 meter per second. Yes, I think the mass would be about 0.1 kg. And when the racket hits the ball, it returns with a velocity of, I think, 50 meter per second. So what would be the change in momentum? What would be the change in momentum? Okay, let us calculate the initial momentum. Ki would be mvi, m is 0.1, and vi is 30. The answer would be 3 meter per second. No, no, the answer is not 3 meter per second. The answer is Newton seconds. Okay. Yeah, I forgot about telling you about the unit. So the unit is 3 Newton seconds. And what would be about final momentum? The final momentum is mvf, and mass is 0.1, vf is 50, the answer is 5 Newton seconds. What would be the change? Change is equivalent to, am I doing right? Have you seen some say, okay, pause the video and see whether I have done some mistake. Yes, exactly. I have not taken sign conventions. You do not have to make this mistake. Okay. So if the body is returning, so the momentum velocity will be minus 50. Okay. So what was the final momentum? It is minus 50. Minus what was the initial momentum? It was 3. Okay. It is not 50 plus 5. The answer is 8 Newton second and minus 8. It is minus 8. Minus 8 states that the momentum is reversed. The momentum is what? The momentum is reversed. Okay, let me extend this question a bit. Consider if the, I think if the Time of striking the ball is 0.3 seconds. What was the force on the ball? Can you calculate it? By my by the same knowledge I have given to you. Yes. Okay. So we know that force times velocity is equal to change in momentum. The force times velocity is equal to change in momentum. So the force is equal to Pf minus Pi upon P, and Kf minus Pi is minus 8, and the time is 0. Let's say 0.2 seconds, and the answer would be 40 Newton seconds. Okay, we'll talk about law of conservation of momentum after some time.